All right. Good morning, everyone. Today is Tuesday, October the 19th. We are on day one of Hyperbolas. So all of you should have your quizzes done for ellipses and, of course, circles. All right, make sure you got your paper, pencil, calculator, maybe even Desmos or GeoGebra if you'd like. But all of you should take notes on paper and not on your computer unless you have like a touch screen and a pen, because it's just too slow. Okay, just like every conic we've done so far, I give you this page and we talk about this double-sided cone and taking a slice to show how we can generate a hyperbola, which you can see here. So a hyperbola really is just two parabolas mirrored. So you got a left and a right or a top and a bottom. So we have two equations for two different types. We have the horizontal. This is the horizontal hyperbola because it opens up left and right horizontally. Then there's that equation. So if you notice on between the two, on this equation versus this equation, do you notice how the x stuff is first followed, and then this one over here, this one is the y stuff first? So for hyperbolas that are horizontal, your x stuff is first, which kind of makes sense because it opens up left and right, which is parallel to the x-axis. The one that is vertical has the y stuff first, and that opens up and down the y-axis. So take note of that. Horizontal, x stuff first. Vertical, the y stuff is first. Also, looking at these equations, what do these equations look like? Like, what comes to mind when you first looked at it? Yeah, it looks kind of like an ellipse equation. What's the difference? Yep, that negative sign between the two terms. So these equations look just like ellipses with one little change, the minus sign. They both have minus signs in between. So like on your quiz, on your test, you may not be told the type of conic it is. You'll have to look at the equation and know the type based on what it looks like. A giveaway, if there's a minus sign, 100% it is a hyperbola. That is the giveaway right there. This makes it a hyperbola, that minus sign. If that was a plus sign, it would be an ellipse. All right, next, we have the center of your hyperbola, which is h comma k. That's nothing new. It's the same as a circle, same as an ellipse. It's the same for hyperbolas. H comma k. But if you notice on the vertical equation, the h and k are switched. Well, that makes sense because your x stuff is now over here and your y stuff is over here. So remember, for the center, h comma k, which is your x comma y coordinate for the center, the h is always with the x, the k is always with the y. So looking at the vertical, the h is with the x, the k is with the y. Don't mess that up. For whatever reason, people get in the habit of just pulling out this number and saying, oh, x comma y, which is going to make your answer wrong if you don't pay attention. So this is h comma k, x coordinate, y coordinate for the center. Also, if you notice on both equations, whether you're horizontal or vertical, the a and the b values stay in the same place. So the a is always under your first term on the bottom. Over here, a is still in the bottom of your first term. B is always in the second term on the bottom. B is always on the bottom of the second term. So that does not change, A and B. It's different than an ellipse. We looked at A and B as kind of like major and minor vertices or major and minor axes. So it's different with hyperbolas. A is the distance from the center to a vertex. So because this one opens up left and right, we know that because x is first. From the center to this point here, that is the distance of A. Same thing for the vertical one. From the center, A is the distance to a vertex. But in this case, we're going in the y direction because, well, y is first, so it opens up and down. So from the center, you would travel up whatever number this may be to get to this vertex. And of course, both equations equal 1, just like ellipses. Horizontal equations. So again, here's the equation for the horizontal. The center is always h comma k. Now, these diagonal lines that I have here, these are not part of the graph, but we still have to graph them because it's basically a grid to help us graph the actual hyperbola, which when we do an example, you'll see what I mean. Without these diagonals, it will be unclear of how wide the hyperbolas are or how narrow they may be. So this is a guide. Remember, asymptotes are imaginary lines that your graph will not touch or cross over. Now, they will approach it like it's doing here, but it will never touch or cross over that line. So the asymptote equation is y equals plus or minus b over a times your x minus h plus your k. This is another form. They just move the k value back to the other side. I can't remember which one they use in the module for your quizzes or your tests, but there's both forms right there, depending on how they want the answer. Also, note this is b over a. You can think of this as being the slope. So rise over run. Now, if you also notice up here in the horizontal equation, the b value is underneath the y. So this is your rise value. And then underneath the x stuff, that is your run. That is the a. So rise over run. So if you remember that, you'll be fine whether we're talking about horizontal or vertical equations, which you'll see on the next page. The vertices, this is really nothing new. So from the center, h comma k, the points to get to this point and to get to this point, all you're doing is you're subtracting a from h, or you are adding a to h. So subtracting a or adding a in the x direction because it's, horizontal, and that will give you the coordinates of your vertices. Yeah, so you just travel from the center left, you travel from the center to the right. So there's the equations. All of you should have this written down in your notes. I will not have these on the example pages because there's not enough room. Going on to vertical equations. So again, here's the equation. Remember, because it's vertical up and down, the y stuff is first. Your center is still h comma k, but identify there's the x, so there's your h value. Identify the y, so there's your k value, h comma k. The asymptote equation is still, it's still similar, if not the same. It's still going to be y equals plus or minus, but now it's a over b instead of b over a. Times x minus h plus k, just like before. This is still rise over run. So if you look at up here, remember your rise is up and down. So look, there's your y value. So there is your rise value. That's why a is on top in this situation. And then your run value, there's your x. So there's your run value, b. Rise over run. Going back to horizontal, it was flip-flopped because A and B, they stay in the same place. A is always gonna be first, B is always gonna be second. Um, but in this case, your rise, well, there's your Y. So there's your rise value is actually your B and not your A this time for horizontal. But going back to vertical, other than that, it's the same equation. And then the vertices, similar to horizontal, but now because your vertices are this point here and this point, we have to travel from the center, h comma k, up and down a distance of a. So from your k value, which is the y value center, you're traveling down a distance of a and you're traveling up a distance of a. And this should be very familiar from when we did ellipses. Really nothing different. Uh, all right, more equations, more diagrams. All right, this is a horizontal equation. I have things labeled. The center is M in this one. From the center to this vertex, that's a distance of A. From the center to your focus point, just like ellipses, that's a distance of C. From the center to, well, this point here, which we would actually plot right here, and we're going to show that that is a distance of B. And what's different, so we are using the Pythagorean theorem. Like if you're given A or B or B or C or A or C, we can find the missing length by using the Pythagorean theorem. Now, this is a little different because we are using it directly. So we have A squared plus B squared. Now, the distance from this center to this diagonal points, that's a distance of C, which is the same distance from the center to your focus point. So we're still using Pythagorean theorem, but A, B, and C are different for hyperbolas. Don't mix them up. And if you have good notes, you could easily kind of refer back one to the other so you can flip your brain so you're not stuck on thinking about one versus the other. So A squared plus B squared equals C squared. Now, we don't have major or minor axis labels. In hyperbolas, we call them transverse axis and conjugate axis. So your transverse axis will always be however it opens. Now, because this one is a horizontal hyperbola, so it opens up left and right, that means this is your transverse axis. So your transverse axis is parallel to the x-axis because it opens left and right. So that means the distance from this vertex to this vertex is a distance of 2a, which makes sense because from the center to one vertex is a distance of a. So a is just half of the full length, just like ellipses. So 2a is full length. Same thing for the conjugate. So again, transverse, vertex to vertex, that is your transverse axis length. And then from B to B, which we're actually going to plot off of the center. So we'll do like from B to B. That is your conjugate axis length. All right, all doing good so far? All right, another diagram with certain things labeled. So we have, this is a horizontal graph because it opens up left and right. We have the two vertices plotted. So distance of A from the center. There's your focus point, which is a distance of C from the center. We have, so I call these our imaginary vertices. So from here to here, this is a distance of B. And of course, from the center to this box, the edge here, that is a distance of c. And that's why a squared plus b squared equals the hypotenuse, which is the c squared. We have these dashed lines. These are the asymptote equations graphed. Because it opens up left and right, this is your transverse axis. It opens up left and right, which means this is your conjugate axis, which we don't have labeled in this diagram. All right. So oh yeah, and then the last one. So I have this page because on your TGA, on one of the problems, you're going to have to use this formula to help solve the problem. That's a word problem, and I will talk about it again once we do the review. But this formula, all this is saying here is that given any points on your hyperbola, it doesn't matter which point you choose. That's why it's just p x comma y. It's anything, it doesn't matter. The distance from one focus to that point minus the distance from the other focus to that point will always equal 2a. So this is an important formula because you'll use that basically to solve for, well, a. Now, this is the distance formula. Now, it is simplified. So if you want to derive this, just pick out the coordinates, and then fill in the coordinates into your distance formula, and it does simplify to this. Same thing for this. Get this coordinate, fill it into the distance formula, simplify it, it gets down to this. So they just simplify it. We're not going to derive it, but you're more than welcome to see how they actually came to this from the distance formula. So all this is remember, the difference is subtraction. So it means this length minus this length is equal to 2a. And remember, 2a is the distance from vertex to vertex. All right, how are we feeling so far about hyperbolas and the different parts before we actually get into a example? Good for people that are actually still here. All right, I'm going to skip this one because I did this one in the 830 class, and we actually only got through one example, which might be the case today. So I'm going to skip this. If you want to see this one worked out, watch the recording at 8:30 and just kind of fast forward to this example. So I think it's more beneficial if I do a different example instead of that one. Let's do this one. All right, everyone. Let's work on this one together because we actually may only get through one example, but let's try to get through two. All right, what is the center for this hyperbola? Forget your parentheses. It does matter. Seven comma -5. Very good, because there's your x, so there's the x coordinate. There's your h, 7. There's your y, so there's your k. And like we know from circles and ellipses, it's always opposite of what you see, so that is -5. So nice job. So we're going to write that down. 7, -5. All right. Oh, by the way, how does this graph open? Like, what kind of graph is this going to be? How do we know it's a vertical up and down? How do we know that? Yeah, the y stuff is first. Very good. So what I like to do is I like to just right next to my equation, I like to just do a little sketch like this just to show that it's a vertical graph. It's going to help me keep things straight of what I'm doing in terms of finding my vertices, my focus, and whatnot. All right. What is my a value? My a value is 5. Yeah. So just like ellipses, we have to square root it. So I'm just going to write 5 squared there and then 8 squared here. And this is my remember a value is always first, b value is always second when talking about hyperbolas. So yeah, very good. So a is 5, which means b is 8. All right. So I'm going to go ahead and graph these points. Also, I don't know if you noticed, but my A and B value are kind of big, and I don't have a lot of room on my graph. So I'm going to count every line as 2 units. So I'll be counting by twos to make it fit. So we're going to go over 7 and down 5. Over 7 and down 5. 2, 4, 6, 7. 2, 4. All right. So that is, I think that's 7 comma negative 5. Do all of you agree with where I put that point? If I counted by twos? Okay, so it looks good. All right, so there's that point. All right, let's let's fill in some other stuff here. Let's go to the easy ones. What's my transverse axis length? Yeah, it is 10. Yeah, remember transverse axis is always 2 times a, and we know a is 5, so that means the length is 10. And then what is my conjugate axis length going to be? 16. Yep, because it's always 2 times b. Asymptotes. Let's go ahead and write that equation. Let's see if all of you can do it before me. So go ahead and write in chat what you think the asymptote equation is going to be. That looks that looks right or pretty close. I actually don't have the answer in my head, but we're gonna run through it together. But yeah, those answers look right. So let's take a look. All right, so we have plus or minus. And remember, so I don't like memorizing equations or formulas if not unless I have to. Some equations you have to like the quadratic formula, you have to memorize that one. There's really no way to kind of rationalize why it works. But this one we can in a way. It's plus or minus. It's the rise over run. So if you look, remember rise is your y value. So there's my y. So my rise is 5. Remember y? Rise over run. So 5 over 8. So 5 over 8. And this is a vertical equation. So if you like just looking at the formula, well, you should have it written down. And then no matter what the equation is, it's going to be x minus h. And our h value is 7, which all of you have. And then we are going to, it's going to be plus your k value. And our k value is -5. So plus -5 makes it a -5. So those of you that wrote it in chat, just the two of you, good job. That is correct. So that's your asymptote equation. Fix my 5. There we go. All right, so let's go back and figure out what the vertices and the focus points are. All right, so to get to my vertices, from my center, which direction will I be traveling? So Enzo says up and down. Anybody else? Yeah, up and down. So, and we know that because this is why I kind of do the sketch right here. So from the center, to get these vertices, we have to travel up and down. So we are traveling up and down. How many units do we have to go? To get to our vertices. So hopefully you have notes. So the distance from the center to a vertex is a distance of A. So I am traveling up and down how many units? 5. Yep, 5 up and 5 down. From that center, I'm going up 5 units. Remember, I'm counting by twos. So 2, 4, and then 5. And then I'm going down 5 from the center. 2, 4, and then 5. All right. My 2 vertice points, they look good. All right. Now, so my vertices, coordinates, 7, comma. Now, we could just use the graph, assuming it's accurate, or I can just do the math, right? So -5. So let's do the bottom one here. So we are traveling down 5 units. So -5 minus 5 is -10. So there's that first, that bottommost point, that vertex. And then the other one, we are traveling up 5 units from -5. So -5 plus 5 gives us 0. And we can confirm these points visually because we ended up graphing them first. And we can see that, yeah, that's definitely 7 comma 0, and that's definitely 7 comma -10. Let's go ahead and graph our conjugate axis vertices, the ones that are, I call them imaginary vertices, because they're not actually on the graph or really part of the graph. So from the center, we are going to go left and right 8 units. So I'm going to do that. So I got 2, 4, 6, 8. 2, 4, 6, 8. Next, I am going to do, well, I should actually do my focus point first. How do I find my focus point? My coordinate. Well, how do I find my focus point? Both of them. I need to find C first. Yes. So how do I find C? Yeah, the Pythagorean theorem. So everyone quickly do that. I'm going to do it on the screen as well. Hopefully nobody's watching me on how to do the Pythagorean theorem because it should be super easy. All right, 5 squared plus 8 squared. All right, radical 89, which does not simplify further, as far as I know. All right, so to graph this point, because we're not using Desmos, we're doing it by hand in this case. Um, how do I plot my 2 points, my 2 focus points? What do I do? Yeah, Enzo says we have to add and subtract C from the center up and down. So from the center, we're going to go up and down whatever C is equal to, which is radical 89. And I believe, rounding radical 89, I think it's about 9.4. So we're going to travel up and down 9.4 units. So let's go ahead and do that. So from the center, I go up 9.4 and down 9.4 to plot those points. Remember, we're counting by twos on this graph. So 2, 4, 6, 8, 9. So slightly above that line. And then 9.4 going down from the center. 2, 4, 6, 8. Nine. All right. Is that good enough? That good enough? Okay. All right. So on the graph, it's good enough for being a sketch. All right. Now let's go ahead and put those, the focus actual coordinates. So the x values are not going to change. That's just going to be 7 comma whatever. Now, remember, in this class, I don't want to see any rounded answers. I don't want to see any decimals. I don't want to see any mixed fractions or any fractions that are not simplified. So we have to use the exact number, radical 89. So from the center, which is at -5, we are going down radical 89 and up radical 89, which is pretty easy because you just have to write just that. So the first coordinate is 7 comma -5 minus radical 89. And then the other coordinate is 7 comma -5 plus radical 89. All right. So kind of similar to ellipses, really nothing different. All right, let's go back to the graph. We're kind of jumping back and forth. We actually could have just saved the graph for the end after we got everything filled in, but it doesn't really matter. All right, next, we're going to draw our box around our vertices and the conjugate vertice points too. I'm going to use a dashed line. That's going to look like this. All right, so there's my box around my vertice points. Next, we need to draw the asymptote lines. And this is actually super easy. We actually don't need to use this equation when we're graphing them because the lines will travel through the diagonals. So if you just do a straight line through the diagonals, you graph it perfectly. So I'm going to use my line tool. And I would do a dashed line, but Desmos doesn't allow me to do a dashed line, unfortunately. All right, so there's my two asymptote lines. And this is why we do the box. It saves us a lot of trouble because we can easily draw these two lines by using that grid. All right, next, now it's time to actually graph the hyperbola. And also, the point of doing this grid, you have the box, you have these lines, the whole point, because it tells us how wide we make our hyperbola. So without them, it could be really steep or it could be super wide, right? So this tells us really how wide it's going to be. So let's go ahead and graph that. And remember, the graph starts from the vertices. It does not start from the focus point. For some reason, especially when this class is done in person and you have a live, in-person test and you have to do all this by hand, common mistake, people like to start from the focus and do your hyperbola, which is incorrect. Remember, this is your focus point, not a vertice. So we start from the vertex and it goes out. Remember, and it's an up and down one. So we shouldn't make that mistake either. So from the vertex, it's nice and wide. Nice and wide. And then the other one too, from the vertex, nice and wide. Don't forget your arrows. I saw on the TGA, I don't know if it was the last one or the first one, people submitted graphs and you didn't put arrows at the end of your graph. And I'm like, it goes on forever. Were you not taught you have to have arrows? It goes on forever. It doesn't stop. And then we're done. That is the finalized graph. On your TGA, I need to see, well, the actual graph itself. I need to see your center plotted, your two vertice points plotted, your focus points plotted. You can even plot, well, and I need to see the two lines for your asymptotes plotted. You don't have to plot these two vertices, and unless you're doing it by hand. If you're doing this by hand, yes, I do want to see those points, and I also want to see the box. But I don't think you can easily plot a box in Desmos. So if you use Desmos to show the graph on your TGA, if you don't have the box, I won't mark it wrong, but I will be looking for everything else because I want to know that you know how to plot all the little pieces as if you're doing it by hand. Not, I'm not testing you if you know how to enter this equation in Desmos and hit enter and expect to get points. I need to see the different parts of it. So keep that in mind. You know what, Enzo? I thought someone was going to bring that up. Yes, I should put arrows on my asymptotes if they were actually part of my answer in terms of the actual graph. But yeah, these asymptote lines do go on forever, and just to humor some of you, I will put arrows on them. All right. And that's it. That is it. So hopefully it didn't seem too difficult. You know, if you can do ellipses fairly well, this is really not that much different in terms of like calculations of finding your focus points and knowing how to find the vertices based off of the center. Yeah, they just take practice. Oh yeah, you know, there's plenty of places to mess up on. Plenty of places. But yeah, we spent about almost a half hour on that problem, maybe about 20 something minutes, 25 minutes maybe. We don't have enough time to do another one. Um, you guys want to try to do one more? All right, let's do this one. We will go over time today, and that's fine. If you guys have another class to go to at 11:30, feel free to leave and watch the rest of the recording later. But I will go ahead and finish this problem with all of you. But let me give all of you some time and let me know. So hit the green check when you are done with this problem. And when everyone's done, we will run through it real quick. Just waiting for a couple more of you to finish. All right, going to quickly write the answer down for this. Looks like a lot of you put the answer in chat. So the center is 10 comma negative 6. The A value is 2. The B value is 9. The vertices, by the way, this one opens up left and right. So I just like to do that next to my equation just so I know what's going on. So that means we're traveling left and right for the vertices and the foci. So the vertices, we're traveling left and right 2 from 10. So 10 minus 2 is 8. And then 10 plus 2 is 12. The foci, we have to do the math. So it's like 4. So 4 plus 81 is 85. The square root of 85, does that simplify further? Square root of 85? No, it doesn't. Okay, so I got C is radical 85 by doing the Pythagorean theorem. So that means we are traveling from the center. We're traveling left radical. Oops. Yeah, that's a radical sign, by the way. Radical 85, and then comma negative 6. And then we are traveling to the right, radical 85, comma negative 6. Transverse axis length, that's just going to be 4. And what's the conjugate axis length? 18, right? Yeah, we just double it. Asymptotes, y equals plus or minus rise over run. So it looks like we're going to have 9 over 2. And then x minus h, which is 10. And then plus your k value. K value is negative 6. So plus negative 6 makes it a minus 6. And then we graph it, right? We graph it. Let me quickly graph it. So we're going to have to probably count by 2s again, it looks like, right? So yeah, over 10, down 6. I'll count by 2s. 2, 4, 6, 8, 10, 2, 4, 6. So there's my center. My A value is 2, so left and right 2 units. So left 2, right 2. My B value, or we'll do the, we'll do the B value, which is 9, so up and down 9. 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. I'm going to do my box right now. And then I'll do my lines going through. All right, now I need my focus points. Radical 85, what is that decimal equivalent? A 9.2? All right, so we'll go up and down. I'm sorry, we'll go left and right, 9.2. Let's see. Two, 4, 6, 8, 9. So somewhere over there. 2, 4, 6, 8. Did I count that right? Hold on. 2, 4, 6, 8, 9.2. Yep. 2, 4, 6. 2, 4, 6, 8, 9. All right. So somewhere like right there. All right. Good enough, right? And then we have to graph it. So starting from the vertex, the vertices, and this is a very wide graph. So you see how it kind of follows that, right? And then, and that's why we do this grid. It really tells us how wide to make our hyperbolas. Not the best graph, but sorry. All right, good enough, I think. Good enough. All right, how did everyone do on that problem? All right, looks like everyone who's responding got it right. And of course, Desmos is a great way to check to see if our answer is correct. Yeah, it's not. It's really not. It looks scarier than it really is. But all right, guys, we'll call it there. Make sure you do the modules, of course, to practice more examples. But as always, thanks for coming, and I hope you learned something. I will see you all tomorrow for day 2 of Hyperbolas. All right, have a great rest of your Tuesday.